Here's a worked example on Markhov chains. I'll need you to copy this down, so press pause and press play when you've finished copying it down. Now our first job in this situation is to form two matrices. The first one's called an initial state matrix, otherwise known as a probability matrix, and that in fact is going to be a row vector. The second one's called a transition matrix. The transition matrix is going to look different. It's going to be a 2 by 2 matrix. Now to solve these problems, in a nutshell, this is all you do. You multiply your probability matrix or initial state matrix by the transition matrix, and the result of that you multiply by the transition matrix again. And the result of that you multiply by the transition matrix, and over again, over and over it goes. So now at the end of the process, what you should find is what's called a steady state matrix. In other words, the probabilities settle down to a value that doesn't change. Now we're not going to get to that in this example because it will take about 13 iterations, but we'll see what happens to Bill and Ben's petrol situation after about 4 weeks. So to form our matrices, we just use the information that's given, and the probability matrix is in this case relating to the initial market share that Bill and Ben enjoy. So we can see that Bill has got 48% of the market. Now I know that we don't usually use headings in matrices, but this will help us keep track of what's going on. So Bill has 48%, so we always write these, well I do anyway, as decimalised forms of percentages. So Bill's got 48% and Ben 52%. Okay, remember what that matrix is called? It's called the initial state or probability matrix, and we're going to call it P0, probability 0. 0 normally means initial state in mathematics. So now we need the transition matrix, and this is how it goes. This is a market share problem, and it's the market share that's going from Bill and Ben back to Bill and Ben. So if I do it like this, you'll get the hang of it quickly, I'm sure. Bill and Ben. Okay. Now, Bill's, what it says here is he's lost 5% of his customers to Ben. He's lost 5. So from Bill to Ben is over here, and he's got 0.05 loss to Ben. That means he's retained 95% of his customers at the end of the first week. In a similar way, we can see that Ben has lost 8%. So 8% have gone from Ben to Bill. 8% have gone from Ben to Bill. So we put 8% there, and that means he's hung on to 92%, hasn't he? 92%. Alright, so to get the market share at the end of the first week, all we do is we multiply this vector here by this matrix here. That's going to give us what we might call P1, the market share really, after the first week. So let's see how it looks. Make some room. Alright, so what we need to do is, as I said, we need to multiply P0 by the transition matrix. So, and that's going to give us P1, so the market share after the first week. Okay, so remember how we do this? We go row by column when we are multiplying matrices, row by column. Okay, so in this case P1 is going to equal, alright, so it's 0.48 times 0.95 plus 0.52 by 0.08, and you're going to find that that comes to 0.4976, and by multiplying this row by that column, in other words by going 0.48 times 0.05 plus 0.52 times 0.92, we are going to get a result of 0.5024. 5024. Okay, let's stop for a minute and reflect on what we've got. So what these numbers are telling you is that Bill's market share has gone up from 48%, the initial state, to 49.76% after the first week, and there's been a commensurate decline in Ben's share from 52% down to 50.24. So to find out what happens after the second week, all you do is you multiply this matrix, the P1, by the transition matrix. Now this one doesn't change; it stays the same all the time. So you're just multiplying the P matrices, if you like, the probability matrices, by this transition matrix. This one changes every time up to a certain point. So what I'd like you to do is multiply P1, this one, by the transition matrix and see what you get. Alright, compare your answer to what I got. So remember how it goes. You go that row by that column, that row by that column. In other words, to slow it right down, 0.4976 times 0.95 plus 0.5024 times 0.08. That's your answer there. And then that times that plus that times that goes there. By the way, if you're using a Casio calculator or some other calculator that's really reasonably sophisticated, order of operations will take care of the calculations there. Alright, so let's press pause at this stage and see how you go in terms of getting P3. What will you do to get P3? You'll multiply P2 by your transition matrix. So there you go, that's P3, and if you want to pause now, when you press play you'll see P4. And there you have it, P4. So how do we interpret that again? What we are saying here is that according to this model, which has probably got, you know, a few hairs on it, after 4 weeks, the market share for Bill will be 53.78%, and Ben will be 46.22. Remember that Bill started on 48%, so he's gone up a full 5%, and Ben started on 52%. Will that trend continue forever? Well, actually no, it doesn't. It turns out that what happens is that you reach what's called a steady state, and just for the insatiably curious, I can tell you that to get some of this out of the way, that what happens is that Bill will end up with, I think it turns out to be 61%, 61.54%, and Ben ends up with 38.46, and that's where the rot is arrested for Ben. What you should do now is actually press pause and have a go at something like this. See, what I'm saying is that things will stop changing when this market share is achieved. So we could call that P infinity, if you like. Okay, and see what happens when you multiply this matrix by this probability matrix by the transition matrix. And what you should find is something interesting. Okay, so there's the probability matrix there. Multiply that by this transition matrix and see what happens. and that's where we'll leave it for now. Thank you, bye bye. I'll press pause now.